Absolute value. For a real number a, the absolute value is written as the letter A inside of these two straight bars and is a positive number. Two vertical bars around a number or expression are used to represent the absolute value of the number or expression. So the absolute value of a positive number is the positive number. So for example, the absolute value of 5 is just 5. The absolute value of 0 is 0. The absolute value of a negative number is the negative of that number, which will result in the positive value. So the absolute value of negative 5 is negative 5, which simplifies to positive 5. The absolute value can be used to represent the distance of a number from 0 on a real number line. So the absolute value of negative 5 is the distance from 0 to negative 5, which is 5 units. The absolute value of positive 5 is the distance from 0 to positive 5, or 5 units. In general, the absolute value of a real number, a, is defined as, if a is greater than 0, it's defined as being equal to a. However, if a is less than 0, the absolute value is negative a. Determine the absolute value of a number. The absolute value of 3. Since 3 is greater than 0, the absolute value of 3 is 3. The absolute value of negative 7. Since negative 7 is less than 0, the absolute value is defined as negative of what's inside those absolute value signs, which works out to be positive 7. Let's write real numbers in order from least to greatest. So the first step of these is to rewrite them without the absolute value signs. It's also going to be the easiest to order them if we change them all to decimals. So our first number is the absolute value of negative 6.5. By definition, this means that this is the negative of negative 6.5 or positive 6.5. Our next number is the number 5. There's nothing to simplify there. Then we have the absolute value of 4.75. Since 4.75 is greater than or equal to 0, the absolute value is just 4.75. Our next number is negative 3.4. It's not inside absolute value signs, so we don't need to do anything to change it. So it stays as negative 3.4. Our next number is the absolute value of negative 12 over 5. Since what's inside those absolute value signs is less than 0, to evaluate it, we're going to have the negative of what's inside there. So we end up with positive 12 over 5, which works out to, as a decimal, 2.4. Our next number is an absolute value sign, or is an absolute value expression. The number is less than 0, so when we take the absolute value, we take the negative of what's inside the absolute value, so it becomes positive 0.1. The next number, negative 0.01, is not inside absolute value signs, and so we don't make any changes. The last one is inside absolute value signs, so it becomes the negative of negative 2.5, or positive 2.5, which as a decimal is 2.5. The next thing we want to do is to order all of these numbers now from least to greatest. So we're looking for the smallest number. We're going to start with our negatives. So the smallest value that's up there is negative 3.4. The next one is negative 0.01. So we're getting closer to 0. That's all of the negative numbers that we have. So moving on to the positive side, the smallest number that we have would be 0.1, which started off as the absolute value of negative 0.1. The next largest decimal that we have is 2.4, which started as the absolute value of negative 12 over 5. Then we have 2.5, which started as the absolute value of negative 2 1/2. Then we have 4.75, which was the absolute value of 4.75, followed by 5, and finally the absolute value of 6.5. We can also do some evaluating of more complicated absolute value expressions. So when we evaluate, we want to simplify what's inside the absolute value signs first and rewrite the equations then without absolute values. So if we're simplifying, the absolute value of 4 is 4 minus the absolute value of negative 6. Because negative 6 is less than 0, the absolute value of that is the negative of negative 6 or positive 6. We now have 4 take away 6, or negative 2. In the next one, we want to start again by simplifying what's inside that absolute value. So we have 5 take away 3. Simplifying inside the absolute value, 2 take away 7 is negative 5. Evaluate this absolute value expression. The absolute value of negative 5 is less than 0, so we want to take the negative of that. So the negative of negative 5 is positive 5. Following the order of operations, we need to multiply before we subtract. So it's 5 take away 3 times 5 is 15. 5 take away 15 is negative 10. In part C, again, following our order of operations, we're working inside those absolute value signs. We want to simplify inside the brackets first, so rewriting everything else. 5 take away 7 is negative 2. Simplifying the exponent. If I have negative 2 all squared, it means negative 2 times negative 2, which is positive 4. The next step is to multiply. So again, this is still all inside the absolute value sign. Negative 2 times 4 is negative 8. Adding negative 8 plus 6 is negative 2, still inside the absolute value sign. What's inside the absolute value sign is a negative number. So to evaluate the absolute value, we need to do the negative of negative 2 or positive 2. Our final question is an application of absolute values. On stock markets, individual stock and bond values fluctuate a great deal, especially when the markets are volatile. Volatile means that they're moving up and down. A particular stock on the Toronto Stock Exchange opened the month at $13.55 per share. It then dropped to $12.70 a share, increased up to $14.05, and closed the month at $13.85. Determine the total change in the value of the stock market for the month. This total shows how active the stock was. So I don't want to know where it ended up compared to the beginning, but I want to see how much it was moving up and down. So I need to look at each change. That first change happened when it went from $13.55 and dropped to $12.70. So it ended up at $12.70, started at $13.55. If we were to subtract those numbers, we would end up with a negative value, which shows me that it dropped. In this question, we're not concerned with whether it actually goes up or down, but how much it changes. And so really, we're just worried about the absolute value of that. Then we're going to look at the next change. The next change is an increase from increased to $14.05. So it started at $12.70 and increased to $14.05. So again, we're interested in the absolute value of where it ended up compared to where it started in that change. And finally, one final change. Started at $14.05, and closed at $13.85. So again, it dropped. So to show this drop, starting with $13.85 minus $14.05. So we had 3 different changes throughout the month. So we have 3 different absolute value expressions to help us with that. Let's evaluate those absolute value expressions. So inside the first one, if I have 1270 minus 1355, shows a loss of 85 cents, or decimal 85. In the second one, 1405 minus 1270 shows an increase of $1.35. And the last piece, again, is another drop. So it's a negative decimal 2, or a negative drop of 20 cents. Evaluating the absolute values, this one becomes positive decimal 85 plus positive 135 plus positive decimal 2. Adding all 3 of those up, show me that the activity of that stock market or stock was $2.40.